Hi, statistics students. We are now in section 7.3. So this is kind of a variation on what we were doing the last couple sections. We've been talking about confidence intervals and sample size, but so far we've been talking about confidence and intervals and sample size for means, to try to estimate the mean or the average of something, like the average weight of all the pink elephants in the world. But now we're going to talk about confidence intervals when you're trying to estimate a proportion or a percentage, like what percentage of all American voters support a certain candidate, or what proportion of all cola drinkers prefer Coke to Pepsi, or what percentage of all Lincoln College students own a yo-yo. So the notation, the symbols that we're going to use, here's what everything stands for. We use the letter P, just a plain old lowercase p, to stand for the proportion of the population that fits whatever category we're talking about. If we were talking about the proportion of cola drinkers that prefer Coke to Pepsi, P would stand for what proportion of all cola drinkers prefer Coke to Pepsi. And then a letter P with this pointy thing on top of it, and that's pronounced P hat, because it's like P is wearing a hat. Yes, that's really what it's called. That's the proportion of the sample that fits the category. So if you took a survey and asked 100 people whether they prefer Coke to Pepsi, P hat would be the proportion of the people in your survey who fit that category. And that's going to be how many, the actual number in your survey that fit that category, divided by how many people you surveyed altogether, the sample size. Then we use Q hat, the letter Q wearing a hat, to stand for the proportion of the sample that does not fit the category. And so that's going to be 1 minus whatever P hat is. So, for example, suppose we really are interested in finding out what percentage of Lincoln College students own a yo-yo. So you go out, you randomly select 50 Lincoln College students and ask them if they own a yo-yo. Hey, dude, you own a yo-yo? And it turns out that 13 of those 50 people you asked say, yes, I own a yo-yo. So then that's 13 that do out of 50 in all that you surveyed. That's 0.26 or 26% of your sample. So that would be P hat, 0.26. Q hat would be 1 minus 0.26, which would be 0.74. 26% of your sample do own a yo-yo, so the other 74% do not own a yo-yo. And then P without the hat, just the plain old letter P, would stand for the proportion of all Lincoln College students who own a yo-yo. We don't know what that is, but if you could survey every single student in the whole college, that would be how you would find out for sure exactly what P is. But based on what we saw in our sample, we can get a pretty good estimate of what the population proportion is. We can come up with a confidence interval so that we can say we're pretty sure that the proportion of all Lincoln College students who own a yo-yo is somewhere between something and something. So the formula that we use to calculate that kind of confidence interval looks like this. It's got a P in the middle. So instead of ending up with mu between two numbers, you're going to end up with P between two numbers. And the formula for what those numbers are, on the low end, you take P hat minus Z sub alpha over 2 times the square root of P hat times Q hat over N. And on the high end, you have the same formula, but with a plus instead of a minus. P hat plus z sub alpha over 2 times the square root of p hat q hat over n. Remember the order of operations. The minus or the plus happens last after you do all of these other operations, the multiplication and the division and the square rooting. If you just put it all into a calculator that knows about the order of operations, it should do it correctly. The z sub alpha over 2 is the exact same z sub alpha over 2 that we were talking about back in section 7.1. So that depends on what your confidence level is. We've talked about what the p hat and the q hat and the n all stand for. And one reminder, we usually want either 2 or 3 digits after the decimal point. That would be p to either the nearest whole percent or the nearest tenth of a percent. And when you're doing your calculations, make sure you put in numbers for p hat and q hat that have at least as many decimal places as what you want in your final answer. So if you're giving your final answer to 3 places after the decimal point, make sure the number you put in for p hat has at least 3 places after the decimal point. So now let's go back to our example. We've randomly selected 50 Lincoln College students and asked them if they own a yo-yo. 13 of them do. Now, what's the 95% confidence interval for the true proportion of Lincoln College students who own a yo-yo? So in this example, N, our sample size, is 50. That's how many we asked or sampled or surveyed in all. And we already saw how we calculated p hat. 13 out of 50 is 0.26. And then q hat is 1 minus p hat. 1 minus 0.26 is 0.74. And for a 95% confidence interval, the number we use for z sub alpha over 2 is 1.96. If you don't remember that, go back and look at your notes from 7.1. Now, when we put all those numbers into the formula, here's what it looks like. It's 0.26 minus 1.96 times the square root of 0.26 times 0.74 over 50, and then 0.26, oops, this should have been a plus. I meant to change that to a plus 1.96 times the square root of 0.26 times 0.74 over 50. So let's put that into the calculator and see what we get. 0.26 minus 1.96 times the square root of 0.26 times 0.74 divided by 50. Notice that's all under the square root sign. Some calculators, when you push the square root button, stick in a parenthesis. Some don't do anything, and if yours doesn't do anything, make sure you put parentheses around this whole expression so that you're taking the square root not just of the 0.26, but of the whole 0.26 times 0.74 over 50. So that comes up as 0.138416790. So to 3 decimal places, that would be 0.138. And if I put the same thing in, but with a plus instead of a minus, 0.26 plus all that other stuff, the calculator gives me 0.3815 and so on. If I want that rounded to 3 places after the decimal point, 0.381 with a 5 after it would round to 0.382. So to the nearest thousandth or tenth of a percent, that would be 0.382. So here's what our answer looks like. P is between 0.138 and 0.382. That is, under the circumstances based on that survey we did, we can be 95% sure that somewhere between 13.8% and 38.2% is the percent of Lincoln College students who own a yo-yo. Now, the part of the formula that comes after the minus or the plus is called the margin of error. And here, that part of the formula comes out to be 0.122. So the interval went from 0.26 minus 0.122 to 0.26 plus 0.122. It was 26% plus or minus 12.2%. So I'm going to end this video right here and then pick it up in part 2 for another example of this kind of thing, confidence intervals for a proportion, and then we'll also talk about sample size, how big a sample you need when you're trying to estimate a proportion. See you then.